The second part of today's lesson is going to be talking about a few more ways that we can factor polynomials. So on this slide, as you look at the very top, you can see that it says the difference of two squares. So again, that hopefully is a review. I know it's been a while. We just did the difference of two squares to finish our previous example. You got a chance to do it again in the at your boards problem, number 1. And there's two more methods that we're going to look at today. Factoring using the sum of two cubes or the difference of two cubes. All right, so again, this process is going to happen every time if you have the sum or difference of two perfect cubes. Now, I want to be clear, we do have the sum of two cubes. We did not have the sum of two squares before. All right, so that is new. And I want you guys to use the acronym SOAP. All right, so that's what I want you to focus on to help you when you factor using the difference or sum of two cubes. If you think about SOAP, and what this means is we have same for S, opposite for O, and then AP is always positive. So I'll repeat that. Same, opposite, always positive. So if you just look at this, right, I'm going to show you an example with the sum of two cubes. Right, the sum of two cubes has addition. Obviously, it's the sum, so that's why it says addition. So here we go. Same, opposite, and then always positive. Okay, I'll show you how that works for the difference of two cubes. All right, so it's subtraction for the difference. So same as the one before, so that's why it's subtraction. Opposite, so we went from subtraction to addition, and then always positive. So if you think about SOAP, so again, if you think about using this acronym SOAP, same, opposite, always positive, the first sign is going to be the same as what it is in the actual problem. Then the sign after that will be the opposite, and then the last sign is always positive. So then if you know that, all you have to remember is the factors. The first factor is a plus b or a minus b, and then those three terms in the last factor are a squared, ab, and b squared, always. The signs are the only thing that will throw you off, okay? So let's do an example together. We have x cubed plus 27. So the first thing I do when I look at these is I want to know, okay, if this is the sum of two cubes, then what cubed gives me each of those things? So the first thing is x. X to the third power is x cubed, all right? Do you know the cube of that will give you 27? And that is going to be 3. 3 times 3 is 9. 9 times 3 is 27. So 3 cubed is 27. So my a and my b, if you will, my a and my b from the previous slide are going to be x and 3. So I'll just write down the form that we have on the previous slide. We have a plus b is the first factor, then a squared minus a times b, and then remember always positive, plus b squared. So I literally just replace where it says a, I'm going to put x, and where it says b, I'm going to put 3, and that will give me my factors for this polynomial. All right, so I'm going to write x plus 3 times, this is going to be x squared minus x times 3 plus 3 squared. I went ahead and put it in parentheses for you so you can see all that stuff. On the second one is a little bit, I wrote too many x's. Sorry, I made a mistake. Too many x's. That should just be a 3. All right, because b is 3. All right, so I put in parentheses to show you that I just replaced it, as I said. Now again, I'm not going to leave it like that. I'm going to write my answer as x plus 3 times x squared minus 3x plus 9, because 3 squared is 9. Just like before on the previous example, even though this looks very different than what I started with, it actually is no different. One is factored and one is not. If I were to distribute x times all 3 of these, and then I were to distribute 3 times all 3 of these, like we did last week, you would get, after you combine like terms, x cubed plus 27, because many things would make 0. All right? So again, as you get a little bit more comfortable with doing this process, this step here, you can go ahead and just leave out. All right, that step right there, if you can do this stuff mentally, like put 3 and x together and then 3 squared to make 9, that's fine. But for now, if you need to show all the work, those are the steps that I would show. Okay? So if you look at your boards, you're going to do the same process. Number 1 is subtraction. So in the example, we use addition. So make sure you're using the right form. For number 1, it is subtraction, so the difference of 2 cubes. And number 2 is addition, the sum of 2 cubes. So it should be very similar to the example that we did together. All right, so go ahead and stand up and try those.